A company has migrated its application from a monolith architecture to a microservices-based architecture. The development team has updated the root 53 simple record to point myapp.mydomain.com from the old load balancer to the new one. The users are still not redirected to the new load balancer. What has gone wrong in the configuration? This is option 1, this is option 2, this is option 3, and this is option 4. Your time starts now. Time up. Option 1. The health checks are failing. This option is incorrect as the health checks are used to determine the health of the load balancer and its instances. If health checks are failing, it wouldn't prevent users from being redirected to the new load balancer. So this option is incorrect. Option 2. The CNAME record is misconfigured. This option is incorrect as a CNAME record is used to map an alias or subdomain to a canonical name of a server or another domain. While a misconfigured CNAME record could cause issues, it's not the most likely cause in this scenario. So option number 2 is incorrect. Option 3. The alias record is misconfigured. This option is incorrect as an alias record is used to map a domain or subdomain to an AWS resource such as an elastic load balancer. While a misconfigured alias record could cause issues, it's not the most likely cause in this scenario. So option number 3 is incorrect. Option number 4. The TTL is still in effect is correct as TTL, time to live, is a setting that determines how long DNS resolvers cache a DNS record. When you update a DNS record, it can take some time for the changes to propagate due to TTL. In this case, the users are not still redirected to the new load balancer because the TTL of the old record is still in effect. So option number 4 is the correct answer. Question number 2. The engineering team at a company wants to create a daily big data analysis job leveraging Spark for analyzing offline or online sales and customer loyalty data to create customized reports on a client-by-client basis. The big data analysis job needs to read the data from Amazon S3 and output it back to S3. Which technology do you recommend to run the big data analysis job? You have to select two options. This is option number 1, this is option number 2, this is option number 3, this is option number 4, and this is option number 5. Your timer starts now. Time up. Option number 2. AWS Batch. AWS Batch is not designed for big data frameworks like Spark. And also, it's better suited for running generic compute-heavy batch jobs rather than big data processing. So this option is wrong. Option number 4. Amazon Athena. Athena does not support Apache Spark. And also, it is not designed for running complex big data jobs or processing frameworks like Spark. And also, Athena is better for ad hoc SQL queries, not Spark-based analysis. So this option is incorrect. Option number 5. Amazon Redshift. This is a wrong answer as Redshift does not support Apache Spark. And also, it is built for structured data in a warehouse, not for processing raw data in S3. And also, while Redshift is great for SQL-based analytics, it's not suited for Spark-based big data workflows. So this option is incorrect. Option number 1. AWS Glue. This option is correct as Glue supports Apache Spark, which is ideal for big data processing. And also, it integrates seamlessly with Amazon S3 for both input and output. And also, Glue simplifies the job setup with its managed infrastructure. So this option is correct. Option number 3. Amazon EMR. This option is correct as EMR is built specifically for big data use cases. And also, it fully supports Apache Spark, making it a perfect fit for the job. And also, EMR integrates with S3 to read and write data. It's cost effective because you can scale the cluster as needed. At last, option number 1 and 3 are the correct answers. Question number 3. The data engineering team at an e-commerce company has set up a workflow to ingest the clickstream data into the raw zone of the S3 data lake. The team wants to run some SQL-based data sanity checks on the raw zone of the data lake. What AWS services would you recommend for this use case such that the solution is cost-effective and easy to maintain? You have 4 options for this question. This is option number 1, this is option number 2, this is option number 3, and this is option number 4. Your timer starts now. Time up. Let us analyze the answers. Option number 1. Load the incremental raw zone data into an EMR-based Spark cluster on an hourly based and use Spark SQL to run the SQL-based sanity checks. This option is incorrect, as loading data into an EMR-based Spark cluster on an hourly based would require a lot of overhead, including provisioning and managing Spark clusters. While Spark SQL is great for big data processing, this approach might be overkill for some simple SQL-based data sanity checks. So, option number 1 is an incorrect answer. Option 2. Load the incremental raw zone data into RDS on an hourly basis and run the SQL-based sanity checks. This option is incorrect, as loading data into RDS on an hourly basis would require a lot of overhead, including provisioning and managing database instances. RDS is better suited for transactional workloads, not for running ad hoc SQL queries. Option number 2 is an incorrect answer. Option number 3. Load the incremental raw zone data into Redshift on an hourly basis and run the SQL-based sanity checks. This option is incorrect, as loading data into Redshift on an hourly basis would also require a lot of overhead, including provisioning and managing Redshift clusters. While Redshift is great for data warehousing and analytics, it's not the best fit for running simple SQL-based data sanity checks. So option number 3 is also an incorrect answer. Option number 4. Use Athena to run SQL-based analytics against S3 data. This option is correct, as using Amazon Athena is the most cost-effective and easy to maintain solution for this use case. Athena allows you to run SQL queries directly against data stored in S3 without having to load the data into a separate database or cluster. This approach eliminates the need for provisioning, managing, and scaling infrastructure. At the end, option number 4 is the correct answer. Let's go to the next question. A retail company wants to share sensitive accounting data that is stored in an Amazon RDS DB instance with an external auditor. The auditor has its own AWS account and needs its own copy of the database. Which of the following would you recommend to securely share the database with the auditor? You have 4 options. This is option number 1, this is option number 2, this is option number 3, and this is option number 4. The 4 options are not fitting into the screen. So if you want some more time, you can pause the video and take your time. Your timer starts now. Time up. Now let us analyze the answers. Option number 1. Export the database contents to text files, store the files in Amazon S3, and create a new IAM user for the auditor with access to that bucket. This option is incorrect, as exporting the database contents to text files and storing them in S3 might seem like a simple solution, but it's not the most secure or efficient way to share a database with an external auditor. This approach would also require the auditor to import the data into their own database, which could be time consuming and error prone. So option number 1 is the incorrect answer. Option number 2. Set up a read replica of the database and configure IAM standard database authentication to grant the auditor access. This option is incorrect, as setting up a read replica of the database and configuring IAM standard database authentication would allow the auditor to access the database, but it would not provide a separate copy of the database for the auditor. This approach would also require ongoing database administration and synchronization. This option is incorrect. Option number 3. Create a snapshot of the database in Amazon S3 and assign an IAM role to the auditor to grant access to the object in that bucket. This option is incorrect, as creating a snapshot of the database in S3 and assigning an IAM role to the auditor would not provide a usable copy of the database for the auditor. Snapshots are backups of the database, not a usual copy. So, option number 3 is an incorrect answer. Option number 4. Create an encrypted snapshot of the database, share the snapshot and allow access to the AWS Key Management Service encryption key. This option is correct, as creating an encrypted snapshot of the database, sharing the snapshot and allowing access to the AWS KMS encryption key is the most secure and efficient way to share a database with an external auditor. This approach provides a separate encrypted copy of the database so that the auditor can use without requiring ongoing database administration or synchronization. So at last, option number 4 is the correct answer. Let us go to the next question. A file hosting service uses Amazon S3 under the hood to power its storage offerings. Currently, all the customer files are uploaded directly under a single S3 bucket. The engineering team has started seeing scalability issues where customer file uploads have started failing during the peak access hours with more than 5,000 requests per second. Which of the following is the most resource efficient and cost optimal way of addressing this issue? This is option number 1. This is option number 2, this is option number 3 and this is option number 4. The options are not fitting into the screen, so if you want some more seconds to answer, you can pause the video and take your time. Your time starts now. Time up. Option number 1. Change the application architecture to create a new S3 bucket for each day's data and then upload the daily files directly under that day's bucket. This option is incorrect, as creating a new S3 bucket for each day's data might seem like a good way to spread out the load, but it would lead to a large number of buckets which can be difficult to manage and might even hit AWS bucket limits. So option number 1 is an incorrect answer. Option number 2. Change the application architecture to create a new S3 bucket for each customer and then upload each customer's files directly under the respective buckets. This option is incorrect, as creating a new S3 bucket for each customer would lead to a large number of buckets which can be difficult to manage. Additionally, this approach might not address the scalability issue, as a single customer could still upload a large number of files. So, option number 2 is the incorrect answer. Option number 3. Change the application architecture to use EFS instead of Amazon S3 for storing the customer's uploaded files. This option is incorrect, as using EFS instead of S3 would not address the scalability issue, as EFS is designed for file level storage whereas S3 is designed for object level storage. EFS would also require more management overhead. So option number 3 is incorrect. Option number 4. Change the application architecture to create customer-specific custom prefixes within the single bucket and then upload the daily files into those prefix locations. This option is correct, as creating customer-specific custom prefixes within the single bucket and uploading daily files into those prefix locations is the most resource-efficient and cost-optimal way to address the issue. This approach helps distribute the upload load across multiple prefixes, reducing the likelihood of hitting S3 request limits, keeps all the files within a single bucket, making management easier, and does not require creating multiple buckets or switching to a different storage service. At last, option number 4 is the correct answer. That's it for today's video. Congratulations for answering 5 questions today. There are 2 playlists, one for Solutions Architect and one for Cloud Practitioner. You can go to these playlists and practice as you wish. That's it for today's video. I'll meet you in the next video. Till then, keep learning, keep practicing, keep exploring. Thank you and bye.